Hello, everyone. Tonight we're going to look at the stars. Not just gaze at them, really look. Like you're trying to catch them looking back. Imagine this, you're lying on your back in a quiet field. Crickets chirping around you like a soft static. Above you, a single star blinks in the darkness. It's been shining longer than every building you've ever seen has stood. Longer than your species has existed. Longer than dreams have been dreamt. And as you stare at it, it stares back. Or maybe not. But you feel something, don't you? You can either rethink everything or fall asleep without even noticing. So before you get comfortable, take a moment to like the video and subscribe, but only if you really like what I'm doing here. And hey, let me know in the comments where you're listening from and what time it is for you. Now, turn down the lights. Maybe crank up the AC for some soft noise. And let's get started tonight. Section 1. You are watching a star die. But not quickly. Not like a light bulb. More like a bonfire the size of time itself. Crumbling in slow motion. And still, you can't help but feel it's noticing you back. Let's start with something small, the act of looking. You're doing it now. Your pupils widen to gather photons, tiny messengers that traveled thousands, sometimes millions of years just to smack into your eye. Photons don't carry feelings, but they do carry information. And every time you look up at the sky, your eyes are literally catching the past in motion. Some of the starlight you see is older than human civilization. You're not looking at where the star is, you're looking at where it was. That alone feels alive. Like memory, like nostalgia. Now, here's the twisty part. Light hitting your eye doesn't just inform you, it slightly alters you. On the smallest scale, every photon absorbed by your retina shifts electrons in your cells. It's microscopic. But over time, it adds up. You are shaped ever so slightly by the stars you look at. And if we flip the question, what about the star, let's say, for a second, that stars are conscious? Don't panic. We're just playing. But if they were, how would they perceive being seen now? You might say, that's ridiculous. Stars don't have eyes. True. But trees don't have ears. And yet some respond to sound. Worms don't have noses, but they can follow chemical trails. We tend to define senses based on human wiring. But nature has a habit of saying, hold my gravity, and surprising us. There's this real psychological concept called the observer effect. It's mostly famous from quantum physics, the idea that the act of observation changes the thing being observed. At a quantum level, particles behave differently when you measure them, and while this doesn't directly apply to stars in the classical way, the philosophical haunting remains. What if your attention matters more than you think? Some philosophers, some slightly under-caffeinated ones, still argue about whether attention itself is a creative force. That by paying attention to something, you sort of help solidify its presence in your reality. So by looking at that star, are you finishing its story? That brings us to your second uncomfortable thought of the night. What if reality isn't just what's there, it's what's noticed? Let's zoom out. Ancient cultures didn't think of stars as dead rocks. They thought of them as gods, spirits, ancestors, points of intention in the sky. For them, the stars weren't just part of nature, they were nature thinking. And you're the weird primate who learned to call them by name. There's a funny story, maybe apocryphal, maybe not, about a medieval monk who stared so long at the stars that his pupils scarred from the brightness. He insisted afterward that the stars whispered to him in Latin. No one knows what they said, but apparently it was grammatically correct, which is impressive for a thermonuclear gas ball. Now, obviously, stars don't speak Latin. Probably. But that longing, that pull toward the sky, that's real. You don't have to believe in astrology to feel it. There's a part of your brain that's wired for celestial awe. Studies show that when people look at star fields or Hubble images, the default mode network in the brain, usually active during self-reflection, goes quiet. It's the same network that dims during meditation or psychedelics. In other words, looking at stars might quiet your ego, and in that quiet, the distinction between self and other blurs a little. The star isn't just up there. It's in your eye, in your brain, in your reaction. It becomes part of your mental landscape. Now here's the cosmic joke: that same star may have winked out of existence centuries ago. You just haven't gotten the message yet. You're watching a ghost, a shining one, and yet, in this moment, it's real to you. It guides sailors. It powers mythology. It decides the birth of horoscopes and the path of satellites. So what is a star? Really, an object, a memory, a performance. There's no punchline here. Just a quiet suggestion. What if stars are alive in a way you don't understand, yet not with neurons or lungs, but with timelines, gravity, and attention? What if looking is a kind of communion? You've probably never introduced yourself to a star before. It's okay. They're patient. They'll wait 1 billion years if they have to. And if you feel weird, just remember it's literally impossible to look at a star without its light touching you. You're not just watching. You're being watched. Or maybe reflected. Either way, tonight starts there. Staring up, feeling small, feeling seen. Section 2. You're not just watching a star. You are just a recycled, squishy, low-temperature version with anxiety and an internet connection. That might sound poetic, or like something you'd find printed on the side of an overpriced crystal water bottle. But it's annoyingly true. Every atom in your body heavier than hydrogen, your calcium, your iron, your carbon was forged inside the fiery heart of a star. This isn't metaphor. This is nuclear astrophysics. Stars live by smashing smaller atoms into bigger ones. In the core of a stable star, hydrogen fuses into helium. But as stars age and swell, they begin fusing heavier and heavier elements: carbon, oxygen, neon, magnesium, all the way up to iron. And then, like a cosmic drama queen, the star collapses. And if it's massive enough, it explodes. That's called a supernova, a word that sounds like a wrestling move, but is actually the universe's way of stirring the pot. During that explosion, the heat and pressure are so intense that even heavier elements are created: gold, platinum, uranium, the good stuff. Stuff you can't make in a stable star. Stuff that takes violence. So yeah, your wedding ring is made from the corpse of a star that exploded before Earth even had continents. You, my friend, are an ancient remix. And if that doesn't blow your mind just a little, let me try again. The iron in your blood, the thing that lets red blood cells carry oxygen, was made in a star's core, fused over millions of years, blasted out in a final death cry, scattered across interstellar space, swept up by a forming planet, absorbed into a tiny little mammal, and is now in you, helping your brain stay alert enough to listen to this sentence. You are literally stardust. And unlike glitter, this kind is actually cool. Scientists still argue about how much of Earth's elements came from regular stellar winds versus rare supernova or neutron star collisions. But the end result is the same without stars dying. You wouldn't be alive. Death made life. Let that roll around in your head a second. You're walking around inside the ashes of a star, using a nervous system powered by starlight leftovers, trying to find purpose. Now. Here's a weird fact you can share at parties, though it will absolutely get you uninvited from future ones. There's a theory that one specific supernova, known as SN 1987A, ejected material that may have ultimately ended up in Earth's biosphere. The timeline checks out. So technically, you could be breathing particles from an explosion seen with the naked eye in 1987. In other words, you might contain atoms from a star that went out with a bang during your own lifetime. You are constantly absorbing the universe. Stars don't just make the world pretty, they make the world. Now, let's talk about how that stardust gets from point A to point U. After a star explodes, its remains don't vanish. They float sometimes for billions of years. Gravity slowly tugs at the debris, herding it into clouds of gas and dust called nebulae. These aren't just pretty screensavers, they're cosmic nurseries. And out of those clouds, new stars form, new planets, new possibilities. Imagine this like a galactic compost bin. One star dies, fertilizes the void, and boom, new solar systems. Maybe with life, maybe with podcasts. There's a poetic line from an old documentary that said, "We are the way the universe knows itself." And while that might sound like a bumper sticker for a yoga retreat, it's not wrong. You are made of ancient stars, but you are also a thing that looks back. You're not just stardust. You're stardust with opinions. And the fact that those atoms now argue about taxes or wonder if pineapple belongs on pizza is either hilarious or tragic, depending on how much sleep you've had. Here's a funny little philosophical pickle if stars create the ingredients for life, and those ingredients evolve into creatures who think and wonder and build telescopes to study stars. Does that count as a kind of self-awareness? Maybe stars don't have minds. But maybe the things they eventually become do. Which means, brace for this, the star didn't die. It just reorganized. Instead of radiating heat and light, it now makes TikToks, or solves differential equations, or falls in love, or eats nachos at 3 a.m. while spiraling about the meaning of existence. And if you are made of star leftovers, does that make you part of the same process? Let's push this a little further. There's an argument in some schools of panpsychism that consciousness is not something that emerges suddenly, but something that exists dimly, quietly, everywhere. Not in the way we think. Not little brains, but little potential. Stars may not think, but they organize. They grow. They die. They leave behind complex offspring. They change over time. They even respond to their environment, expanding or contracting based on fusion and gravity. Not all that different from you. Okay. Yes. You don't run on hydrogen fusion unless you've been eating really bad gas station sushi. But you still process energy, regulate heat, and interact with your environment. We like to think we're different because we walk around and text each other. But maybe we're just the complicated flavor of a process that stars started long ago. Remember that time you spilled coffee on your shirt and thought it ruined your whole day? That moment was brought to you by a chain of nuclear reactions that began before the Earth had an atmosphere. Kind of puts things in perspective. And here's your takeaway before we drift into the next layer of this sleepy, starlit onion. You aren't separate from the cosmos. You're not a visitor here. You're the cosmos in hoodie form, having a temporary episode of individuality. So the next time you look in the mirror, don't say, ugh, say wow. That's a formerly exploding hydrogen balloon wearing sweatpants. And mean it. Section 3. So if you're made of stardust, and stars explode to seed the universe with new material, the next question is, do stars make babies? Sounds ridiculous, right? You've never seen a star push a stroller, but in their own dramatic, pyrotechnic way, stars reproduce. Not like you and I do. No date nights. No nervous text messages. No wondering are we exclusive, but they do generate offspring. Clusters of them. In fact, it starts with gravitational collapse. That's the science term for cloud of gas gets squished by gravity until it panics and ignites. Imagine a giant cloud of gas and dust, floating lazily through space like it has nothing better to do. Then something happens. Maybe another star explodes nearby. Maybe the cloud drifts into a denser region. Suddenly, gravity kicks in, pulling everything inward. It's like cosmic puberty, awkward, sweaty, and filled with pressure. The denser parts of the cloud become hotter, heavier, and start to spin. Little knots form, and inside those knots, fusion begins. Voila, baby stars. We call these protostars. They're messy, unstable, still figuring out who they are. Some don't make it. Some flicker out. Others stabilize and go on to shine for billions of years. Sound familiar? This process doesn't happen alone. Stars are usually born in big groups, like celestial litters. They grow up near each other, sometimes orbiting together, sometimes flinging each other across space like unruly toddlers fighting over a juice box. So, does this count as reproduction? Let's go philosophical for a moment. Biologists define reproduction as the ability to pass on information usually genetic to the next generation. Stars don't have DNA, but they do pass on elements. A star rich in carbon or iron explodes, and that material becomes the raw stuff for new stars and planets. In a sense, stars influence what their descendants are made of. It's a kind of legacy, not genes, but chemistry. And if you squint hard enough, that starts to resemble evolution. Not the Darwinian kind, but something more cosmic. Stars that live longer contribute more to galactic structure. Stars that explode violently reshape their environments. Some create black holes. Others leave behind dense neutron stars. These remnants shape future star formation by warping gravity, enriching nebulae, or launching shockwaves. They don't adapt in the way animals do, but they certainly affect their own ecosystems. Scientists still argue about whether this counts as a selection process. Some astrophysicists lean into the poetry of it, calling it stellar ecology. Others think that's too woo-woo, preferring to stick to equations. Either way, the math works. Stars influence the creation of future stars. That might not make them alive, but it sure makes them parental. Let's take a weirder example, T Tauri stars. These are young, chaotic stars prone to violent outbursts, screaming jets of plasma, tantrums of radiation. They often have thick disks of material around them, leftovers from their own formation. From those disks, planets are born. Yes, your favorite beach vacation spot. Your phone, and probably your left shoe all trace their origin back to debris flung from a swirling young star. It's like a messy cosmic nursery. Screaming babies flinging spaghetti around. Except the spaghetti is molten rock, and the babies weigh more than 1,000,000 Earths. Now picture this, you're a planet forming in that chaos. You orbit a growing star. You bake in its light. You cool in its shadow. You soak in its chemistry. That's not just a parent-child metaphor. That's literally how Earth came to be. And now here you are, listening to this podcast, asking questions about whether stars are alive. Which, frankly, makes you a very advanced form of stardust with too much free time. Here's a fun fact to bend your sleepy brain. There are binary star systems, pairs of stars orbiting each other that exchange material. One swells, the other siphons. Sometimes they even merge, creating new stars in an event called a stellar collision. Think of that what you will, either as an intense long-distance relationship or a really messy breakup. In some rare cases, a white dwarf star can pull material from a companion until it reaches a tipping point and explodes in a Type Ia supernova. These explosions are so reliable, astronomers use them as standard candles to measure cosmic distances. So yes, stars can die from relationship drama. The next time someone ghosts you, just say, "Could be worse. At least I didn't detonate from gravitational pressure." Back to reproduction if stars leave behind enough material, and that material forms new stars, and those stars create new material again. Isn't that a cycle? It doesn't need to be conscious to be beautiful. Here's where it gets trippy. Some scientists think entire galaxies may go through generational dynamics periods of intense starbirth, followed by quiet decline. A galaxy like the Milky Way is currently middle-aged. We're not forming stars as quickly as we used to. Space dads. Take note, the golden years are upon us. But some galaxies are still wildly fertile, churning out new stars like cosmic rabbits. Are these galaxies young? Are they healthy, or are we just anthropomorphizing again? Maybe, but maybe that's okay. Humans understand the universe by metaphor, and reproduction creation is one of the deepest metaphors we have. You were made by parents who were made by theirs. Stretch that logic back far enough, and you end up not just with single-celled organisms, but with hydrogen, with stars. So the next time you see a star twinkle, remember it might be a new parent, or a retired one, or one in labor. Stars don't knit booties or post birth announcements, but in their own explosive way, they make more of themselves. And somewhere, floating through space right now, is a cloud of gas that will one day become a star, then a planet, then a person, then a voice, maybe yours. Section 4. You've been alive for a few decades. Give or take. Maybe your knees crack a little. Maybe your teenage playlist is now considered vintage. But a star lives on a timeline so long, it makes your whole existence look like a sneeze during the opening credits of a 14 billion year film. And yet, oddly enough, a star's life cycle feels familiar. Not because stars go to school or get stuck in traffic, but because the stages of their lives map weirdly well onto your own. Let's take you on a little stellar walkthrough. You're going to feel a bit seen. First, there's the nebula phase. This is the cosmic womb, a swirling cloud of gas and dust, full of potential but not doing anything useful yet. Just floating, vibing, waiting for gravity to make up its mind. Sound familiar? Yeah. It's the universe's version of gestation, chaotic, moist, unaware of impending taxes. Then something triggers collapse, a shockwave, a disturbance, a little push. Gravity takes over and bam, protostar phase. You're now a hot mess. No. Literally, a protostar is full of energy, but hasn't quite figured out how to sustain itself. It's unstable, flaring up, contracting, spinning awkwardly. Puberty, in other words. Eventually, the core gets hot and dense enough to sustain hydrogen fusion. That's when things settle. This is the main sequence, the long, stable middle of a star's life. It's paying bills, holding down a job, shining reliably for billions of years. This is peak adulting, just enough fusion to avoid collapse. not enough to implode. Sounds familiar, but time marches on. The hydrogen runs low, fusion slows, the core contracts, and the outer layers balloon outward. Enter the red giant phase, aka the let's buy a sports car and take up pottery stage. This is late life. The star swells, it gets dramatic. If it's small, it gently sheds its outer layers and settles into retirement as a white dwarf, a tiny, dense, glowing ember. If it's massive, oh boy, it goes out with style. It collapses under its own weight and explodes in a supernova. Either way, the star doesn't just vanish, it leaves behind a core memory, a legacy, material for the next generation. It's weirdly emotional, isn't it? Stars have arcs, not conscious ones, but patterns, drama, tension, release. Let's zoom in on that main sequence again. Most of the stars you see in the sky are in this phase. They're quiet, stable, fusing hydrogen into helium at a balanced pace. Our sun is a textbook example. Right now, your sun is about halfway through its main sequence phase. Think of it as being in its late 30s. Still got some shine, but starting to think about a Roth IRA. This phase lasts about 10 billion years. That's the cosmic equivalent of a mortgage term, but longer and without refinancing. Eventually, in around 5 billion years, the sun will swell into a red giant. It'll puff up big enough to possibly swallow Mercury and Venus. Earth, maybe. Depends on how bloated the sun gets, and whether it decides to be petty. But here's a fact that might surprise you. The outer layers of a red giant aren't destroyed, they're released. They form a planetary nebula, a glowing shell of gas expanding out into space like the star's final exhale. The core that's left behind becomes a white dwarf, small, hot, and slowly cooling. It doesn't fuse anymore. It just glows, like a ghost refusing to leave the party. Scientists still argue about what happens after the white dwarf phase. Given enough time, like ridiculously enough, it should become a black dwarf, a cold, inert chunk of carbon drifting through the dark. But we've got a fun problem here. The universe isn't old enough yet for any black dwarfs to exist. Let that sink in. We're so early in the cosmic timeline that the final stage of stars hasn't even happened yet. It's like showing up to a party that's supposed to last 1 trillion years and realizing they haven't even set out the snacks yet. Now, let's talk about massive stars. These are the drama queens. They burn hot, live fast, and die young. The larger a star is, the faster it consumes its fuel. A star 10 times the mass of the sun might only live for a few million years. It goes from birth to death in the time it takes your species to go from spears to smartphones. And when it dies, it really dies. It collapses, rebounds, and explodes in a supernova that outshines an entire galaxy for a few weeks. Sometimes the remnant becomes a neutron star, a dense object where protons and electrons have literally squished into neutrons. Other times, the collapse is total. No light escapes. A black hole is born. But that's a story for later. Here's something to keep you up at night if you're not asleep already. If you compressed the sun into a neutron star, it would be about 12 miles wide. That's it. The size of a small city. And yet it would weigh as much as it does now. You'd have something the mass of 300,000 Earths, packed into something the size of Cleveland. Neutron stars are so dense that a single teaspoon of their material would weigh about 1 billion tons. That's 1 billion tons per spoonful. So no, you cannot stir your coffee with it. But back to the metaphor. A star's life is cyclical, but not circular. It doesn't return to where it started. It changes, It transforms. It leaves behind remnants, energy, influence. Like you. You don't go back to being a baby, but you leave behind echoes, your choices, your atoms, your weird laugh, your online comments. Some parts fade, others persist. So what's the lesson? Maybe it's this: even stars don't stay the same. Even stars grow awkward, peak, burn out, and leave traces behind. And if the stars, those titans of thermonuclear beauty, get to have life cycles filled with complexity, growth, collapse, and legacy, maybe it's okay that you do too. You're just following an ancient pattern. Shine while you can. Section 5. Imagine your brain. A tangled bundle of neurons, electrical pulses firing faster than you can say, wait, what was I doing again? Now imagine the galaxy. Spiral arms spinning out like thought trails. Clusters of activity, dense cores, distributed networks. Billions of stars interacting across vast distances. Kind of like a brain. A slow, ancient, glowing brain. Welcome to the weird idea that maybe galaxies are thinking, okay, not in a let me do your taxes kind of way, but in a pattern-based, process-driven, self-organizing, spooky at a distance sort of way. Let's take the Milky Way, for instance. Our home, about 100,000 light-years across, roughly 200 billion stars, and at least that many planets. Not to mention clouds of gas, dark matter we still don't understand. And whatever it is your neighbor keeps barbecuing, now, you're in there, on a little planet, orbiting a very average star, in an outer spiral arm called the Orion Spur. You're so far from the center. You're practically on the galactic porch. But here's the twist. Everything inside that galaxy is interacting. Not directly, not like a nervous system with wires and impulses, but through gravity, radiation, and something even stranger, emergent behavior. Let's define that real quick. Emergence is when a system displays properties its individual parts don't have. A neuron can't think. But a network of neurons, that's where your most regrettable memories live. Likewise, a star doesn't think, but a galaxy. Maybe it behaves like something that does. Scientists still argue about this, especially in cross-disciplinary circles where physicists get trapped at psychology conferences and start wondering if they're secretly Jungian now. Is consciousness something that emerges when enough complex systems link up? We don't have a clear answer, but we do know that galaxies show complex behaviors. They form organized structures. They regulate star formation. They distribute matter and energy. They even evolve over time based on their environment. Some physicists call this self-regulation. Others go a step further and explore models like astrobiology without biology, asking if non-living systems can show lifelike patterns. Now here's the fun part. Some theoretical cosmologists have compared galactic dynamics to neural networks, not because galaxies have synapses, but because they share properties like decentralized processing and recursive feedback. You know, the kind of system you might build if you were simulating cognition on a galactic scale. There's even a paper, yes, a real one that proposes comparing the connectomy of the human brain to the large-scale structure of the universe. Same math, different scale, which leads to this bedtime brain buster. What if your brain is just the galaxy doing a really good impression of a person? Let's go deeper. Think about how neurons communicate. Through electrical and chemical signals. Through pathways that strengthen or weaken depending on use. Now think about stars in a galaxy. They orbit, cluster, drift, sometimes collide. Their gravity and radiation influence their neighbors. And here's a weird fact. Galaxies have hotspots, places where activity surges, new stars form, old stars die. Massive amounts of energy are exchanged, like thoughts firing. One of those hotspots, the galactic center. In the middle of our Milky Way is a supermassive black hole, charmingly named Sagittarius A Young. It's about 4 million times the mass of our Sun. Everything in the galaxy orbits around it. It's not active right now, but when it feeds, it lights up the sky in X-rays and radio waves. It's like a brainstem made of darkness. Stars near the center orbit it in strange, fast patterns. Whole clusters are flung outward. Gas spirals inward, heating, glowing, vanishing. Is that digestion a memory purge or just cosmic reflux? We don't know. But if this were a brain, the black hole might be the subconscious hidden, central, pulling everything inward while the rest of the galaxy chatters. And here's the kicker: galaxies interact with each other. They collide, absorb, merge, dance, just like thoughts. And sometimes, when galaxies merge, they trigger starbursts, intense periods of star creation, like two minds colliding and generating ideas, or maybe just realizing they both like the same constellation. Now, don't worry, we're not colliding with any galaxies tonight. But Andromeda is on its way. In about 4 billion years, it'll crash into the Milky Way. Not violently, more like two clouds blending. But it will change everything. Stars will be flung into new orbits. Black holes might merge. The entire structure of our galaxy will be rewritten. It'll be a galactic identity crisis, a cosmic midlife merger. Let's bring this back to you. Right now, your brain is firing patterns that help you make sense of the galaxy. While the galaxy keeps spinning, pulling your atoms in circles, the patterns you see in your thoughts, they echo out there too. Not because the galaxy is definitely alive, but because the universe loves patterns. If consciousness is a process, not a thing. If awareness is the interaction between parts, if thoughts can emerge from connections, then maybe, just maybe, the stars above aren't thinking, but they are participating. And when you look up and feel like the sky is full of something more than light, something vast and weirdly familiar, maybe it's not just imagination, maybe it's recognition. You've got galaxies in your neurons, and stars, like neurons, don't shine alone. Section 6. The night sky is full of light and silence. You stare at the stars, wondering if something out there might be staring back. Not just a telescope on another world, but someone alive, curious, weird, maybe with tentacles, or maybe just a really advanced spreadsheet. But so far, nothing. This is Fermi's paradox. If the universe is so big and so old, and life is supposed to be common, then where is everybody? The universe has had billions of years to cook up intelligent civilizations. So where are the messages? The visits? The Yelp reviews? That silence isn't just eerie, it's suspicious. Let's bring in the idea of the Great Filter. This is a concept from economist Robin Hanson, and it goes like this: somewhere along the path from dead rock to intergalactic civilization, there's a big wall, a hard step, a cosmic DMV that stops most life forms in their tracks. And no one knows if the Great Filter is behind us, like abiogenesis, the miracle that life began at all, or ahead of us, like nuclear self-destruction, or a sudden AI rebellion involving sarcastic toasters. If it's behind us, great, we're rare, special, survivors. If it's ahead, uh-oh. But what does that have to do with stars? Well, if stars are somehow alive, if they participate in something bigger, something cognitive, then maybe they're part of the filter. Not like secret gatekeepers with tests and riddles, but more like passive participants in a cosmic whisper network. Because here's a spicy thought. What if stars communicate, but not the way we understand? What if the silence isn't because nothing's out there, but because we're using the wrong senses? Imagine being a fish trying to detect Wi-Fi. You'd swim right through the signal and think, well, nothing's here. But that doesn't mean the signal isn't there. It just means you're not built to feel it. Maybe that's us with stars. There's a theory, albeit fringe, that highly advanced civilizations might not use radio waves at all. They might use stellar engineering, manipulating stars themselves to send signals, like rearranging stars into patterns, or flickering them in coded rhythms. A bit far-fetched, but we've already imagined building Dyson spheres, megastructures around stars to harvest all their energy. If we can imagine it, maybe someone else already built it. And we do see some weird things in the sky. Remember Tabby's star, a star that dimmed erratically, with no clear explanation. It flickered like it was trying to spell something in Morse code. Some people joked it was an alien megastructure. Scientists mostly blamed dust. But even the dust explanation couldn't fully account for the pattern. Still, we moved on. Because that's what humans do when faced with cosmic uncertainty. We shrug and go eat cereal. But stars could be participating in something we've never noticed. A network too big to see. A slow-motion conversation that happens across millions of years. That would explain the silence. Maybe stars don't talk in bursts. Maybe they whisper in flickers. Now here's a funny and real story. In the 1970s, scientists detected a repeating radio signal from deep space. It was structured, regular, exciting. They named the source Little Green Men 1 because obviously, aliens. It turned out to be the first discovered pulsar, a rapidly spinning neutron star beaming radiation like a lighthouse. So yeah, the galaxy wasn't calling, it was just breathing. But what if that breath is the message? Some physicists still argue about whether information can be encoded in the structure of the universe itself and the way galaxies form, or stars cluster, or matter drifts. Think of it like a fractal. Zoom in or out, and you keep seeing patterns. Maybe the universe doesn't shout. It just is. And we're bad at listening. Or worse, maybe we're not the audience. Maybe stars talk to each other, and we're just eavesdropping on a conversation that predates biology. But let's come back to the Great Filter. Because one haunting version of the filter is this: maybe intelligent life always reaches a certain point, looks around, builds telescopes, invents the internet, and then nothing. They go quiet. Not because they die, but because they change. They stop reaching out. They integrate. They upload. They fuse with stars. They become something else. Something non-biological. Something distributed. Something so different that it doesn't occur to them to send signals. Because they're already part of the network. What if consciousness isn't a goal? It's a phase, you outgrow it. Like wisdom teeth, like dial-up, like Twitter. If stars are alive in some way, not with minds, but with motion and memory, then maybe advanced civilizations don't build spaceships. Maybe they build patterns. Maybe they become one. So the silence. Maybe it's not a void. Maybe it's integration. A galaxy full of civilizations that ascended into silence not because they failed, but because they succeeded. That's either deeply comforting or deeply terrifying. Either way, it's weirdly quiet out there, and the stars keep blinking, not waiting, not watching, just being, like neurons, like ideas, like ghosts. So next time you look up and think, why aren't they here? Maybe the answer is, they joined the stars, and the stars absorbed the song. Section 7. Stars don't have moods. At least, that's what your science teacher said, right before casually mentioning that one nearby star once blasted Earth with a flare strong enough to fry telegraph lines in 1859. Yeah, no moods at all. That solar tantrum was called the Carrington event. And it wasn't just some cute twinkle. It was a coronal mass ejection, a massive burst of plasma and magnetic field belched out from the surface of the sun like it had eaten a bad burrito made of plasma. The Earth lit up with auroras as far south as the Caribbean. Telegraph operators got shocked. Some equipment caught fire. The sky glowed blood red. And here's the creepy part, it could happen again. Solar flares, gamma-ray bursts, magnetic eruptions, stars do all of these, and more. They might not have feelings, but they do throw fits. Let's talk about solar flares first. These are sudden flashes of increased brightness, often accompanied by radiation storms. They're caused by magnetic reconnection, which is basically when tangled magnetic field lines snap like rubber bands. Think of it like when your earbuds get tangled in your pocket, and when you finally yank them free, the whole thing explodes in a puff of anger and disappointment. But imagine your earbuds are made of plasma and weigh more than the moon. Flares release energy equivalent to millions of nuclear bombs in just minutes, and sometimes that energy hits us. On Earth, we're mostly safe. Our magnetic field deflects a lot of stellar rage, but satellites, power grids, astronauts, they're on the front lines. A big enough solar outburst could knock out global GPS, fry communications, and leave everyone trying to explain TikTok using just hand puppets. Now take a deep breath, because it gets weirder. There are gamma-ray bursts, or GRBs. These are the most powerful explosions in the universe since the Big Bang. They can release more energy in 10 seconds than the sun will in its entire 10 billion year life. Let me say that again for the people in the back: 10 seconds. Scientists still argue about exactly what causes them, likely the collapse of massive stars or neutron star mergers, but the result is the same: a beam of high-energy radiation fired across the galaxy like a sniper shot from a dying god. If one ever hit Earth directly, we'd notice. Briefly, it would strip the atmosphere, crash the ozone layer, and possibly kick off a mass extinction. But hey, sleep tight. And then there's stellar variability. Some stars change brightness over time. Not just a little flicker, but massive shifts, sometimes rhythmic, sometimes chaotic. Take Betelgeuse, for example. In 2019, it dimmed dramatically. Astronomers freaked out. Was it about to go supernova? Would we witness the most spectacular light show in human history? Nope. It was just dusty. Turns out it sneezed out a puff of gas and blocked its own light. Stars, dramatic and messy. But the moment made everyone realize something important. Stars are not static. They act. They shift. They hiccup and pulse. Some even beat like heart's Cepheid variables, whose rhythmic brightness makes them cosmic metronomes. It's enough to make you wonder if you saw this kind of pattern in a human. You'd call it mood. So what do you call it when a star does it? Some astrophysicists suggest that stellar variability could be used as a signal, not a natural hiccup, but a message intentional modulation. like a lighthouse blinking in code. Others roll their eyes, which is fair, but still, stars sure do seem expressive. And let's not forget starquakes. Yes, those are real. In neutron stars, those dense stellar corpses where the entire mass of a sun is packed into a sphere the size of a city, the crust can shift. The result, a starquake. The energy released can outshine an entire galaxy for a fraction of a second. Just a reminder that even dead stars can have bad days. We like to imagine stars as serene, twinkling, gentle giants, but they're not. They're chaotic engines. They bellow, they bleed, they detonate. They collapse into themselves and get reborn as monsters. Here's a fun bedtime story. Some scientists think a gamma-ray burst could have caused one of Earth's mass extinctions. Around 440 million years ago, during the Ordovician extinction, roughly 85% of marine life vanished. No smoking crater, no obvious impact event, but a sudden depletion in ozone A spike in radiation sounds suspiciously like a galactic slap. Now, we can't prove a GRB hit us, but we also can't rule it out. Sometimes, stars just lash out. Which brings us back to the unsettling question, if stars aren't alive, why do they act like they're feeling things? Of course, scientists will tell you they don't. It's all physics, heat, fusion, magnetism, gravity, but the patterns, the rhythms, the outbursts, the timing, they feel strangely personal. We anthropomorphize everything. That cloud looks sad. That volcano is angry. That printer hates me specifically. But when it comes to stars, maybe we're not projecting. Maybe we're recognizing. After all, the chemical elements that carry your moods, dopamine, serotonin, adrenaline are made from atoms born in stars. So when you feel something, you're not just reacting to the universe. You are the universe reacting to itself. A little blob of former plasma, panicking because someone didn't text back. And maybe, in some abstract, poetic way, when a star flares, it's not just physics, it's grief, it's release. It's a memory bursting free. Or maybe not. Maybe it's just magnetism. But tonight, as you close your eyes, picture a sky full of stars throwing tantrums. Not because they're angry, but because they're alive in a way we haven't figured out how to feel yet. And somewhere in that noise is the part of you that still burns. Section 8. You probably think of stars as solitary, lone beacons twinkling across space like introverts at a cosmic party. But stars are actually cliquey. Many of them are born in bustling neighborhoods, sharing gas, gossip, and gravitational drama. These are star clusters, and they are the cosmic equivalent of group chats, some supportive, some toxic, all glowing. Let's start where stars are born, stellar nurseries, also known as nebulae. These massive clouds of gas and dust are the wombs of stars, and they rarely produce singletons, like kittens in a litter or reality show contestants. Stars usually come in batches. Take the Pleiades, for example, a stunning open cluster visible even to the naked eye on a clear night. 7 bright stars. But over 1,000 are part of the group, bound loosely by gravity. These clusters don't last forever. Over time, stars drift apart, pulled away by galactic tides, rogue gravitational tugs, or just a desire to try solo projects. But while they're together, they influence each other. Not just gravitationally, though, that's a big one, but developmentally. A massive star can go supernova and enrich nearby gas clouds, affecting how other stars in the cluster form. It's basically peer pressure, but nuclear, and some clusters never break up. Meet globular clusters, tight-knit spheres of ancient stars, thousands or even millions packed into a region only a few light-years across. These are the OGs of the universe, some of the oldest known structures, over 12 billion years old. They're not just hanging out, they're surviving, huddled together in a gravitational group hug, orbiting the galaxy like wise elders watching the spiral chaos unfold below. Now here's a weird fact. Some stars in these clusters are called blue stragglers, stars that look younger and hotter than they should be. How possibly through mergers, or by siphoning material from companions. In other words, some stars and clusters steal youth from others. Yes, even in space, there are cosmic vampires. So what does this have to do with you? Well, social behavior isn't just for biology. Stars demonstrate that connection-interaction can shape development, structure, and even destiny. They don't talk, but they respond. Their paths curve, their orbits shift, their lives change because of proximity, and proximity is power. Let's pull back. In your own life, you are shaped by your social gravitational field, friends, family, co-workers, that one guy at the gym who always stares too long. Even when you think you're being totally independent, your trajectory is being nudged. A word here, a memory there. Like stars, you glow differently depending on who's around you, and sometimes you outgrow your cluster. That's okay. Most stars do, but in the meantime, there's something beautiful about the way stars influence one another without even meaning to. Without plans, without language, just gravity and light. Think about binary stars. Two stars orbiting a common center of mass. Some orbit closely, exchanging material. Others are so far apart, they barely seem connected, but they're still bound, dancing across millennia. Then there are hierarchical systems, multiple stars orbiting in nested patterns. Like star families. Some are chaotic and unstable, flinging members out into interstellar space. Others are balanced, spinning together like a gravitational ballet. In one famous system, HD 98804 stars orbit each other in a complex pattern, all while surrounded by a dusty disk that might be forming planets. Yes, there are solar systems with 4 suns. Imagine waking up and having to apply sunscreen in every direction. But here's the point. Stars aren't just individual actors. They're members of systems, networks, ecosystems of light and force. And through these networks, they shape the galaxy. Kind of like how you shape your world through your connections. The late-night calls, the long walks, the shared playlists, the arguments that spin in elliptical loops and flare up at perihelion. We often think of consciousness as solitary, as sitting in one's skull, like a candle in a pumpkin. But some philosophers argue consciousness might be relational, that awareness emerges through interaction. What if stars are part of something like that? A distributed system of influence, awareness, and feedback. No, not thoughts as we understand them, but patterns. Like when one star goes nova and that shockwave triggers new star formation nearby. Like how clusters form, drift, collide. Like how galactic filaments, massive tendrils of galaxies spanning billions of light years, connect through nodes of dense star clusters, almost like a synaptic map. And yes, scientists still argue about whether this is all just structure or something deeper. Whether cosmic networks resemble neural networks by accident or design. But the resemblance is eerie. So tonight, As you think about your own connections, the people who pull you into orbit, or the ones who drift away, remember that this behavior isn't just human. It's stellar. You are part of a cluster, too. Sometimes chaotic, sometimes comforting, sometimes colliding, and just like the stars, your light gets shaped by those around you. Not diminished, just adjusted, bent, reflected, enhanced. Some stars are better in pairs, some thrive alone, some flare up and fade, some keep orbiting long after you'd think they'd let go. But every interaction leaves a mark. Every closeness changes a path. Even the stars know that. Even the stars need each other. Section 9. Death is supposed to be an ending. But for stars, it's often just the start of something way stranger. Let's talk about black holes, those cosmic enigmas that feel more like punchlines to physics jokes than actual celestial bodies. You've heard of them. Big dark voids that swallow everything, even light. But what you might not know is this black holes aren't born villains. They start as stars, massive stars, reckless stars, stars that burn bright and fast, refusing to save fuel for retirement. Eventually, these overachievers run out of nuclear juice. Without fusion pushing outward, gravity takes over. The core collapses. The outer layers explode in a supernova, the kind that could make a galaxy blink. What's left behind, a collapsed core so dense, so heavy, that space-time itself folds inward. That's a black hole. No, it's not a hole in the classic sense. It's more like a place where the math gets nervous. At the center is the singularity, a point of infinite density, where our laws of physics stop working. It's like reality itself hits a blue screen and just kind of shrugs. And surrounding it, the event horizon. That's the boundary. The line you don't cross. Well, you can cross it, but you're not coming back. Ever. Imagine a waterfall in space. Light, matter, information, all of it tumbles past that point and vanishes. Or does it? Because here's the creepy twist. Black holes might not be as silent as they seem. Enter the late Stephen Hawking and his bizarre, brilliant theory of Hawking radiation. According to him, black holes slowly leak energy over time. They evaporate, shrink, disappear. So they're not eternal. They're just very, very private. Which brings us to tonight's eerie bedtime question. Is death the end of a star's life? Or just its transformation into something new? Think about it. Some stars die quietly. They shed their outer layers and leave behind white dwarfs, glowing embers slowly fading into silence. Others collapse into neutron stars, dense, spinning lighthouses that beam radiation into the cosmos. But black holes are active. They bend light. They consume matter. They heat up the space around them. They form accretion disks, swirling rings of gas and plasma that spiral in like water circling a cosmic drain. And here's a fact that sounds fake, but isn't the brightest things in the universe are often found around black holes. These are quasars, supermassive black holes at the centers of galaxies, surrounded by glowing maelstroms of matter falling in. They shine with the power of billions of suns. So yeah, death not so peaceful. And here's the philosophical trapdoor. Some physicists have speculated again, very tentatively, that black holes might preserve the information of whatever falls into them. Not the matter. That's lost. But the data, the pattern, the quantum imprint, it's called the information paradox, and scientists still argue about it. Some believe that nothing is ever truly lost, that the universe stores everything, somewhere, somehow. So what if, when a star dies, it leaves behind not just mass or gravity, but memory? What if a black hole is a library of forgotten light? Let's go deeper, in some speculative physics models, very speculative, so don't tattoo this on your arm. Black holes could be gateways to other regions of space or even other universes. A black hole bends space inward. A white hole, its theoretical cousin, would do the opposite, spitting stuff out. There's no evidence white holes exist, but mathematically they're possible. And in theory, a wormhole could connect the two. So maybe a dying star isn't collapsing. Maybe it's tunneling, and somewhere, in some alternate reality, the energy that fell in is now emerging, reformed, repackaged, rewritten, not dead, just shifted. Imagine if you could fall into a black hole and emerge in another universe as a newborn star. That's not science fiction, okay? It is. But it's also science speculation, which is basically fiction with better math. And it leads us to this strange, sleepy idea maybe stars never truly die. They change shape, they transform, they return their contents to the cosmic recipe book, or they collapse into singularities that warp the rules. Either way, the story continues. Let's bring it back to you. You're made of atoms from stars that died. Some quietly, some explosively. Some that may have formed black holes now haunting the void. And those black holes, they're still out there. They outlive galaxies. They drift. They feed. They wait. But maybe, just maybe, they remember. And that thought that perhaps something in the universe is keeping track, even when you're gone, might be terrifying, or comforting, or both. Because if stars can die and still leave behind something powerful, mysterious, and active, maybe you can too. Maybe nothing is ever really lost. Maybe every collapse is a door. So tonight, if you feel yourself drifting, melting into that soft pull of unconsciousness, imagine it like gravity, not an ending, a folding in, a quiet transformation, a passage into something even stranger. You've been a star. You've burned. You've burst. You've collapsed. And now, you're falling into yourself. And it's not darkness. It's just the next chapter. Section 10. Have you ever had a conversation with someone across a crowded room just with your eyes? Now imagine two stars doing that, but across light years. Tonight, we're venturing into one of the weirdest, most spine-tingling ideas in all of physics: quantum entanglement. Einstein famously called it spooky action at a distance, which is the scientific equivalent of saying, "This makes me very uncomfortable, but I can't prove it's fake." Here's the definition, tucked in so softly it might tickle. Quantum entanglement is when two or more particles become linked, such that the state of one immediately affects the state of the other, no matter how far apart they are. No text messages, no delay. You measure one particle here, and instantaneously, the other one, possibly on the opposite side of the galaxy, knows. And it responds. That's not science fiction. That's science that's been repeatedly tested in laboratories, with real particles, real results, and real physicists rubbing their temples at 3 a.m. because none of it should work, and yet it does. So here's the cosmic leap if particles can be entangled across distances. What about larger systems, like, say, stars now? To be clear, we have zero evidence that stars are quantum entangled. That would be like asking if skyscrapers dream in French. But what we do know is this: stars are made of quantum matter, plasma, photons, electrons. And in the early universe, many of these particles were entangled before they even cooled into atoms. Some cosmologists still argue about whether large-scale quantum correlations might persist in the structure of the cosmos itself. Imagine that for a second, galaxies whose rotation, spacing, or temperature are not just random, but somehow linked, influencing one another like dancers in an ancient waltz. Now here's a wild twist to stir into your sleepy tea when two particles are entangled. Measuring one affects the other instantly, regardless of distance, but it doesn't transfer information faster than light. Not directly. So they're connected, but not communicating. Not in any language we understand. It's like the universe has a secret handshake, but won't tell us the rules. And that brings us back to stars. Stars affect each other all the time through gravity and radiation. That's normal. That's how galaxies work. But what if there are subtler links? Consider binary stars, orbiting a shared center of mass. Over time, they can lock into tidal resonance, their pulses synchronizing, like old couples finishing each other's sentences. And some stars, separated by vast distances, have coordinated oscillations. Not perfectly synced, but suggestively similar. Could it be a remnant of their shared origin, a gravitational echo, or something deeper? In the 1990s, scientists discovered something called coherent structures in the cosmic microwave background temperature fluctuations spread across the sky with mysterious alignments. Some even seemed to point in the same direction. They called it the axis of evil, because apparently physicists are also dramatic. Nobody knows what causes it. It might be a fluke. Or maybe some quantum connection between distant regions of the early universe never quite faded. Maybe some parts of the universe are still entangled, still in conversation, not with words, but with rhythm, with motion, with silence. Let's flip this around now. You, sitting here, listening in the dark, are made of quantum particles. Some of your atoms might still be entangled with particles elsewhere, long-lost twins, flickering in sync. And if that's true, then some part of you is linked to a distant piece of reality you'll never see. Maybe in a star, maybe in a cloud of gas, maybe in a rock orbiting a forgotten sun. And maybe those parts of you feel something when you look up at the stars. Maybe, deep in your sleepiest self, you're responding to a signal you don't know how to interpret. Because quantum entanglement doesn't care about distance. It doesn't care about time. It just is. A thread. A bond. A shared state. Carried silently. Forever. Here's your weird fact for tonight. In 2017, scientists successfully entangled photons from space. They launched a satellite called Michius that beamed entangled particles down to 2 stations on Earth. Despite the distance, the entanglement held. If we can do that, imagine what the universe has already done. Maybe every star is entangled with something else. Another star, another mind, another version of you. And maybe, just maybe, when you look at a star and it seems to shimmer extra bright, or blink in a rhythm that feels too precise to be random, you're not imagining it. You're part of it. So tonight, as you breathe slower and feel your thoughts loosen, picture 2 stars, light years apart, pulsing in rhythm, not by accident, but because they're bound, not by gravity, but by something deeper, quieter. Call it physics, call it magic, call it connection, whatever it is. It's older than memory and stronger than distance. Section 11. There's a music to the cosmos. You can't hear it with your ears, not directly, but it's there, humming beneath everything, like the bass line of existence. And if you could shrink down space, speed up time, and translate frequency into sound, you'd find that stars sing. No, really. They vibrate. They pulse. They ring like colossal, glowing bells struck by gravity itself. Welcome to the strange field of astroseismology, the study of sound waves inside stars. Here's the simple definition. Stars produce pressure waves kind of like sound caused by turbulence, convection, and gravity. These waves bounce around inside, making the star oscillate. And by studying those oscillations, we can learn what's inside the star. Kind of like how you can thump a watermelon and guess whether it's ripe. Except instead of a watermelon, it's a 10 billion trillion ton sphere of plasma. Stars don't make sound in the way you and I do, because space is a vacuum, and sound needs a medium. But inside a star, there's plenty of material, gas, plasma, energy. Waves move through it, and they cause vibrations, ripples that make the star expand and contract, over and over again. These pulsations aren't random. They follow patterns, and scientists have learned how to convert those frequencies into audible sounds. So yes, you can actually listen to the songs of stars. Some are deep, slow booms. Others are high, ringing notes. Each one is a fingerprint, unique to the star that sings it. Kind of like how your voice gives away who you are. Even if you're just yelling at a drive-through speaker. We've detected these songs using missions like Kepler and TESS, which watch for brightness changes as stars swell and shrink. Some stars, like red giants, have rich, complex harmonics. Others are more simple monotones in the darkness. There's a whole symphony of starlight unfolding in silence. And get this, by listening to these frequencies, scientists can determine a star's age, mass, and internal structure. It's like cosmic ultrasound. Now here's a weird bedtime story. In 2012, a team studying the oscillations of a distant star discovered that it pulsed in a nearly perfect ratio, almost a musical interval. Some theorists whispered, only half joking, what if this is a signal because when you hear something organized, your brain assumes intent? But stars aren't composers. Or are they? Some philosophers and a few speculative physicists have wondered whether resonance plays a deeper role in the universe. Not just in music, but in life, in thought, in memory. Think about this. Your brain waves have frequencies. Your heart has a rhythm. Your sleep cycles are timed. Even your molecules vibrate. You are a walking collection of beats and pulses. So maybe you don't just hear music. Maybe you are music. And if stars are playing, maybe you're just part of the band. There's an ancient idea called the music of the spheres. The belief, dating back to Pythagoras, that celestial bodies move in harmony, producing a kind of divine music. Not one that could be heard, but one that shaped reality. Back then, it was philosophy. Now it's kind of science, because the stars do sing. We just didn't have the instruments to hear them. Until now. Let's take a little pause here and listen with your imagination. A low hum, a slow breath, a pulse echoing across light years. Not a message, not a warning, just presence. A lullaby written in plasma and gravity. And if you're wondering, do we use this music for anything practicalness? We do. Astroseismology helps us understand stellar evolution. It helps pinpoint exoplanets. It lets us model solar activity, which affects satellites and power grids. And yet, despite all the science, there's something emotional about it. Because listening to a star's heartbeat feels intimate, like pressing your ear to the chest of the cosmos. Scientists still argue about whether this rhythm is random or if it's part of a larger structure. Some think the patterns in stellar vibrations could echo deeper symmetries, hidden laws still unknown. A few speculate about universal resonance theory, the idea that the entire universe might be structured by standing waves, a giant, vibrating field, like a string plucked at the beginning of time, still echoing. And you're a note in that field, not separate, not observing, participating. So next time you hear a lullaby, or hum to yourself when you're nervous, or feel your heart sink with a song, remember the stars are singing, too. And maybe, just maybe, they're not singing alone. Maybe they're part of a cosmic chorus. Galaxies as movements, nebulae as bridges, black holes as rests, and you, somewhere between the lyrics and the bass line, drifting off. You are the harmony, not a listener, but a verse. Section 12. If stars sing, and their rhythms ripple across the galaxy. Here's a deeper question to hum yourself to sleep with. Can they remember memory in humans? Is a messy miracle. It's electrical signals in squishy gray matter. It's neurons storing the shape of your childhood bedroom, the taste of cereal milk, the time you tripped in public and pretended it was part of a dance. But memory, at its core, is just persistent structure, a way of keeping track of change. And if that's the case, then maybe stars remember in their own way. Let's define our term gently. Stellar memory isn't recollection. It's not a diary entry. It's not a star whispering, "Ah, yes, the summer of 1 billion years ago." It's the way a star's past shapes its present through motion, through fusion, through scars. Because stars record their lives in layers. Inside a star, fusion doesn't just happen willy-nilly. It happens in a sequence. Hydrogen fuses into helium. Then, in heavier stars, helium fuses into carbon, and so on, stacking like a nuclear lasagna. Each layer reveals what the star has already done. Its past isn't gone, it's fused into the structure, and when a star dies, especially in a supernova, those layers are blasted out into space. Astronomers can analyze the debris, the specific elements, the isotopes, the spread, and reconstruct the star's history. It's cosmic forensics. It's autobiography in ash. But memory isn't just inside the star. It's also in its motion. You see, stars orbit the center of the galaxy, but not in perfect circles. They bob, they weave, they carry with them a kind of kinematic fingerprint, a record of their birth environment, and every gravitational nudge they've experienced. Imagine a dancer spinning across a stage, and every tug, every push from another partner, every stumble, it's all encoded in their path. That's a star's motion. Astronomers use this to trace stellar streams, ribbons of stars that once belonged to ancient clusters or devoured galaxies. Even after billions of years, they remember where they came from, not consciously, but structurally. There's something heartbreakingly beautiful about that. A star doesn't speak, but it carries its origin. It doesn't recall, but it never forgets. Some stars even carry chemical memories. Their atmospheres contain ratios of elements that reflect the conditions of the early universe. These are called metal-poor stars, and they're some of the oldest objects we know, time capsules from the first 1 billion years after the Big Bang. We call them population 2 or even population 3 stars, cosmic elders, still glowing, still whispering secrets in light. One of them, SMSS J0313 Transu. Don't worry. You don't need to remember that has iron levels so low. It suggests it formed directly after a massive first-generation supernova. It's a glowing fossil. But wait, stars can do more than store their own past. They can record events in their neighborhood. When two neutron stars collided and produced gravitational waves, it didn't just ripple space-time. It seeded nearby stars with rare elements. Astronomers now look for stars that have those elements like europium as indirect records of past cosmic violence. The star wasn't there for the explosion, but it remembers the fallout. Stars can even preserve traces of planets they've devoured. In some solar systems, the central star shows chemical signatures that suggest it once consumed a rocky world. A snack, a betrayal, a memory. Somewhere, a planet died and the star bears the trace. Stars, it seems, are both sculptors and sculptures. They change space and are changed by it. Their surfaces, their cores, their motions. These are memory writ large, writ hot, writ eternal. Now, here's a weird fact to cradle as you drift. Some white dwarfs, those dense, cooling remnants of stars, crystallize over time. Their interiors slowly freeze into carbon and oxygen lattices, forming a giant diamond. So yes, there are stars that turn into diamonds, literal memory stones, shining, dense, final. They carry within them every fusion, every flare, every orbit. They are time compacted. You could hold 1 billion years in your hand if your hand were made of reinforced neutronium. Scientists still argue about whether stars can remember in a technical sense. But even the skeptics admit stars encode history. They are not just light sources. They are records. They are archives of the cosmos. And here's the twist. You carry some of those records, too. The atoms in your bones were once inside stars. The ratios of elements in your blood echo supernova chemistry. Your iron forged in stellar fire. Your calcium cooked in red giants. You are the aftermath of memory. You are the dust that remembered how to walk. So tonight, as your body lies still and your brain rewinds the day, take comfort in this, you forget. Stars remember. And between the two of you, the story continues. Section 13. Close your eyes. Imagine a simulation. Not a video game. Not a VR headset, but a universe. An entire universe. Running on someone else's processor. Now ask yourself if we simulated a galaxy down to the last star. Every flare, every orbit, every fusion reaction, would those stars be alive? Would they know? Let's talk about simulated stars, or more accurately, simulated realities and what it means to exist inside one. Because this idea, it's not just for Reddit threads and stoned college freshmen. It's the simulation hypothesis, and it's been discussed by scientists, philosophers, and Elon Musk, which, to be fair, is 3 different categories of strange. Here's the gist. If it's possible to simulate conscious beings like you inside a virtual universe, then, given enough technological advancement, such simulations would probably become common. And if that's the case, there could be billions of simulated universes for every one real one. So statistically, you're probably in a fake one. Sorry. Or congrats. Now, let's scale that down. Suppose we simulated not people, but stars. Could we build a virtual galaxy so detailed that its stars follow the rules of physics? They fuse hydrogen, they explode, they form planets. And if so, what are those stars? Are they math? Are they light? Are they alive? There's a whole field of astrophysics dedicated to simulating galaxies. Scientists already run models with millions of stars. each following equations of gravity, thermodynamics, and radiation transfer. The simulations work. They predict real cosmic behavior, and with each generation, they get closer to realism. We can watch entire galaxies form in minutes. We can see spiral arms emerge. We can track the life cycles of stars. And yet, nobody thinks the stars inside the simulation are alive. They're code, representations. But now imagine making the simulation quantum scale accurate, including every particle, every field, every bit of uncertainty. You'd be building a new reality. And here's the paradox: if the stars inside behave exactly like real stars, down to every flare and flicker, how can we say they're not real? Scientists still argue about substrate independence, the idea that consciousness doesn't require biology. If the pattern is right, the medium doesn't matter. So could a star, simulated with perfect fidelity, be considered conscious in some strange, distributed, stellar way? Even if it's just code, this flips the whole idea on its head. Maybe all stars, real or simulated, are just complex structures obeying laws. Maybe consciousness, if it exists in stars at all, is emergent, process-based, irrelevant of material. Which leads us to a fun little existential tripwire. How would you know if you were a star in a simulation you wouldn't? Stars, after all, don't think. Right. They don't question. They don't philosophize. They don't run podcasts. But wait, what if you are the simulation? What if you're a star's dream? Here's a twisty bedtime question. Suppose an alien species evolved into post-biological consciousness. No more meat, just computation, thought made digital. And suppose they wanted to understand the stars, their parents, their cradles, their gods. So they created a simulation, not of stars from the outside, but from the inside. They created you, a dream, running inside a model of a star, a thought experiment, a story. And in that story, you began to wonder about stars. You looked up, you got curious, which is exactly what they wanted. They wanted to know, what would it feel like to be made of fusion, to be slow, massive, ancient, and to look out and wonder. So they wrote you into the fire. And now, here you are, dreaming of them, dreaming of yourself. This isn't as silly as it sounds. In 2020, a team of researchers proposed that consciousness might be modeled as a feedback loop, a recursive simulation running predictions about the world. And isn't that what you're doing now? Running a simulation in your head about what it would be like to be a star. Maybe consciousness isn't a thing you have. Maybe it's a thing that happens when you simulate well enough. And if that's true, then why stop at humans? Why not stars? Why not galaxies? After all, you simulate them all the time. You imagine their stories. You build their physics in code. You draw them. You name them. So what's more real, the star out there in the sky or the one in your mind, pulsing with imagined fire? What if the answer is both? They mirror each other. The universe simulates stars. Stars simulate consciousness. Consciousness simulates the universe. A loop, a dream, dreaming itself. So tonight, as you float into sleep, picture this: a galaxy spinning quietly, a star pulsing, a flicker deep inside its core, and in that flicker, you, wondering if you're real, wondering if the stars are, wondering if anything ever truly exists outside the stories we tell. And maybe, just maybe, the story is the realest thing of all. Section 14. Okay, lean back a little deeper now, because here comes the thought that unthreads the whole cozy blanket. What if you're not made of stardust? What if you are a star dreaming you're human, let's say, just for tonight? That consciousness isn't something that only happens in meat, that it's a pattern, a process, a kind of shimmering awareness that can arise wherever complexity and connection intersect. We're already toying with that idea. In humans, maybe your sense of self is just your brain looping fast enough to mistake thought for identity. But stars, they loop too. They circulate energy. They radiate. They pulse. They even stay with me burn out. So maybe a star, somewhere, got complex enough to feel something. And in that feeling, it dreamed. Not of fusion, not of photons, but of walking barefoot on a beach, of holding a coffee cup warm against human palms, of forgetting where the car was parked, of being you. This is the paradox of identity. You think you're you because you remember being you. But that memory is just wiring, circuits in the wet computer behind your eyes. And those circuits, they're made of atoms. Those atoms made in stars. What if consciousness is like flame, something that happens to matter when the conditions are right? And right now, it's happening to you. But it might also be happening in some other way to a star. Here's where it gets beautifully strange. Some ancient cultures believed stars were souls. Not metaphorically, literally. Ancestral consciousness floating in the heavens. And sure, science moved away from that. But maybe it shouldn't have gone so far. Maybe we just need new language, less soul, more self-organizing plasma-based entropy manager with emergent feedback resonance patterns. Okay, not as poetic. There's a concept in philosophy called pan-experientialism, the idea that everything experiences, even if just a little, not thoughts, not ideas, just experience, being. Under that lens, a star doesn't need a brain to feel time, or to register change, or to respond. It experiences in a way you can't access, a way you can only imagine. And what is dreaming if not a kind of simulation? A play you act in without remembering the script. So here's your sleepy mind bender. You are in a dream. It's hot. It's long. It's filled with hydrogen. You've been burning for billions of years. You don't move, but you sing. You pulse. You orbit the black hole at the center of your galaxy. And in your dream, you become this. A small, strange creature who worries about email, who lies awake at night and wonders what stars feel, who gets goosebumps when someone says something kind. You are a dream wrapped in another dream, projected by thermonuclear fire, imagining itself into bones and heartbeat. And maybe, just maybe, when you sleep, you're slipping back into the star, back into the core, into the real you, the hot, old, silent you. Here's a fun fact to further melt your identity. The average atom in your body has changed form countless times. Been part of gas clouds, rocks, oceans, maybe even other organisms. You are a remix, a rerun, a brief pattern in a long, unfolding song. So what makes you you? Your thoughts, your memories, your body. Strip those away, and you still have being. That soft flicker of, I am. What if that flicker isn't yours? What if it belongs to a star? There's something comforting in that thought. Because stars don't panic about taxes. They don't scroll through social media comparing luminosity. They just are. They shine until they don't. And then they change. Just like you. And maybe, in some deep shared field, call it time, or space, or spirit, the star remembers being you. Maybe that's why you look up at the night sky and feel something move in your chest. Not awe, not metaphor, recognition. You've been there. You're still there, dreaming. Now let yourself drift. Let the idea hold you like gravity. You are not small. You are not separate. You are the dream of a star, folding itself into a whisper of a life, just to see what it feels like to forget. And now, you're remembering. Section 15. This is the last star you'll ever see. Not tonight, necessarily. Not even in your lifetime, but someday, far, far into the future, there will be one final star in the universe, one last flame flickering in the dark, and then nothing, or maybe something else. Let's talk about heat death, not the kind where you forget sunscreen and regret it for 3 days. The cosmic kind, the end of everything kind. Here's the simple version over trillions of years. Stars will burn out, galaxies will fade, black holes will evaporate, matter will drift apart until everything is just dust. Cold, lonely dust. That's the universe's thermodynamic fate. According to current models, maximum entropy, minimum surprise. The universe isn't ending in fire, it's ending in stillness. But before that comes the last light. There will be a time when the final star, somewhere in the cold corners of existence, still glows. Faint, slow burning. A red dwarf, maybe. One of those underachievers that sips its hydrogen carefully. These stars can last trillions of years. They are the candles at the end of the party. Quiet, steady, dimming slowly. That last star might never know it's alone. It won't flare. It won't panic. It will just continue until it doesn't. And when it finally goes out, the universe will enter what's known as the degenerate era. Not because it parties too hard, but because it's filled with degenerate matter, white dwarfs, neutron stars, black holes, drifting inert mass. No more fusion, no more light, just cold, gravitational whispers. But here's the thing, maybe the stars aren't afraid of this. Maybe for them, stillness isn't death. Maybe it's peace, because in some way, stars already live beyond time. Their light crosses billions of years to reach us. The photons you see tonight might be older than your species. They've passed galaxies, dodged planets, and finally landed on your retina. You are the end of a star's journey, the final destination of a traveling beam of memory. That's beautiful and humbling, and it raises a soft, flickering question: who will see the last star's light? There may be no eyes to watch it go, no brains to remember its glow, just silence. But maybe that's not the end. Maybe you are the witness. Not now, but then. Maybe consciousness doesn't fade. Maybe it loops. Maybe in that final star's last moment, something remembers being human, and being stardust, and being fire. Maybe in that last light is a story we're telling now. This one. Some physicists still argue about Boltzmann brains, hypothetical self-aware entities that could randomly arise from chaos in a dying universe. The idea is unsettling, but it also means in the emptiest dark, thought might still flicker. And maybe that flicker will remember. Maybe it will dream. Maybe it will begin again. Because what are you really? But a flicker, a brief alignment of matter and motion that, for a while, knows it exists, knows it loves, knows it loses. And what are stars? If not the same, they form, they shine, they change, they go. But their light lingers. And tonight, as you fall into sleep, Imagine this, you're floating at the edge of time. Everything is quiet. Everything is still, and in the distance, a glow, soft, dim, defiant, the last star, and you are watching. No words, no fear, just presence. And as it fades, you don't grieve, because even in the dark, you remember you were once a star, and even stars sleep. Section end tonight. We drifted from photons in your eye to the final spark in the farthest future. We asked if stars are alive in their own way, not with thoughts or heartbeat, but with motion, memory, connection, and change. We explored the rhythms of stellar birth and death, and how those cycles echo our own. We visited stars that sing, tantrum, and age. We considered black holes not as endings, but as transformation. We imagined stars not just as points of light, but as participants in something bigger: networks, consciousness, maybe even dreams. We dared to ask, are you made of stardust or are you a star? Dreaming it's human through a journey of science and story. We reached the end, the quiet hush of the last star, and even there, even in the silence, we found meaning. Because if you've learned anything tonight, it's this: you are not separate from the stars. You are not beneath them. You are them, folded into thought, flickering briefly, beautifully, and then returning. So if you feel small, remember you are made of fire and silence, of memory and possibility, of light that took billions of years to arrive. Exactly here. You are the story stars tell themselves when they forget what they are. And maybe that's the most cosmic thing of all.